Good morning, everyone. Let's get started. I want to finish off this section on absolute convergence. So what you've got is, I believe it's 5 questions here. We've done most of them. I'm just going to do one of my own just to finish with. And the kind of question you're really going to be asked is this series absolutely or conditionally convergent? We're going to look at what does that mean? Well, absolutely convergent, doesn't that mean that the original and if you make everybody positive, both those series are convergent? But when it's conditionally convergent, isn't this one convergent? But when you make everybody positive, you get something that's divergent, right? And the whole goal is to prove this, even though in the homework all you get is like 3 dots and you pick which one, right? So here is our last kind of example of this. These types of questions are almost exclusively alternating series. Didn't we show you one yesterday where I had the cosine of n pi, but isn't the cosine n pi just a disguised alternating series? So we got a guy like that, and we got a fella here. So the question here is, what kind of convergence does this series has? Is it absolutely or is it only conditionally convergent, right? So first thing is, we're going to just use the original series, and I'm going to cut some corners here and tell you this converges. I would, in a real situation, when I prove that that converges, but this is essentially what I can show you. Can you trust me that it's not too difficult to prove that the limit of that is 0? Can you do that through L'Hospital or divide top and bottom by n, right? And if I call this guy 3n over n squared plus 1, can you imagine after a fair amount of work, I could prove that its derivative was negative and therefore it is decreasing. And if you put those two together, doesn't that mean it converges by the alternating series test? So far, so good. Now, you take the same series and you make everybody positive. And everybody positive tends to be, you just got to do that guy. Would you agree once t disappears, aren't you now looking at a positive series, right? A series with nothing but positive terms in it. So far, so good. Right? Now, proving that that converges or proving that that diverges, because it could do one or the other, right, is where we are right now. But that's not necessarily as simple as it seems, because there are a number of different tests that we know about that we could use to prove what we're interested in. I could do the integral test. And that would work. And if I did the integral test, I would find out that it diverges. I could do the limit comparison test. And if I did, I would prove that it diverges. Technically speaking, I could do what's called the comparison test. But I definitely wouldn't. And if I did manage to do it correctly, which is kind of hit and miss, I would also prove it's divergent. Well, of course, if it's divergent, won't each of the tests tell you the same thing? Because it's divergent, right? It's which test you should use. So don't use the comparison test if these guys are powers, right? Like n's and n squareds and n cubes and square root of n's. Just don't use the comparison test. 50% of the time you might be right, but 50% of the time you will give the wrong conclusion, or at least you'll be proving it in a way that's not valid, which is more likely. So in this case, that's why there's only 2. And now you have a choice. Which of those 2 methods is the least amount of work? Because that's the one you should pick.
The limit
Probably
comparison
the
test.
limit, yeah.
Yes. I think everybody should agree with the it's the limit. Because if you're doing the integral test, and remember you have to do it properly, don't you have to prove that it's decreasing first? And then you have to find the limit from 1 to infinity, right? And in this case here, it would end up being a U sub, and that takes time and all the other bits and pieces. Isn't there a lot of work? And the more things you do, isn't that more opportunity to screw up, right? More steps that you might make a mistake in. So when you're looking at a question like that and you're saying, well, which of the tests should I use? Because I could use A or I could use B. Answer your own question by which one of those two is the least amount of work and pick it. That would be my advice. If there's, if nobody gives you a method that you must use, then pick one that works. So let's start with this guy. And since I'm going to do the limit comparison test, isn't my first job is to find the comparison guy. And we do that by what I call surgery. So what we call the top guy 3n, what will we call the bottom guy?
N squared.
Okay. And that in turn becomes 3 over n. Do you see a p series? I mean, 3 doesn't matter, right? It's a p series. Isn't p equals 1? And isn't that greater than or equal to 1? And you see that this now diverges. So far, so good. Now, a lot of people, unfortunately, think that's the question over with. Oh, I know that it diverges, which it does. But knowing it diverges is not the same as proving it diverges. So what we now need to do to finish this is you have to do the complete test, the limit comparison part, right? We've done the comparison part, we haven't done the limit part. In this case, it's going to be the limit as n tends to infinity of the first fraction, which is that one, divided by the comparison one. Could I have called that guy 1 over n instead of 3 over n? This fella here, could I have called it 1 over n instead of 3 over n?
Yes, because it's only the p, like the power that matters.
Right. So some people don't like numbers, one more place I can screw up. So always, when they do this, they call it 1 over n or 1 over n cubed, whatever it happens to be. I don't mind, I like it that way. So
It wouldn't cancel as pretty.
it doesn't. You're right. It doesn't, which is maybe why I choose not to do it. Are you comfortable about the first guy gets turned up? The second guy, I should say, gets turned upside down, right? And then I'm going to combine the top and combine the bottom. So 3 lines later, we're here. Now at this point, don't we just use the usual rules that we've discovered from various things? Couldn't we do divide top and bottom by n squared and get the answer 1? And couldn't we do L'Hopital and get the answer 1, right? I'm going to do the n squared. I don't know, I kind of like the n squared method for dividing. So it's going to be the limit as n tends to infinity of 3 on the top and 3 plus 3 over n squared. And then you just plug infinity in and you get 1. And by the limit comparison test then, if the limit is a number, any number will do, 40, 3.5, 1. As long as it's a number, then won't this one behave like that? So by the limit comparison test, our series diverges. Now, what do we call a series that when you leave it alone, untouched, it's convergent, but when you make everybody positive, it's divergent? What name do we give to a series that has those?
Conditionally
Right.
convergent.
So that's it. So your answer to this whole load of work is conditional convergent. So you'd pick the dot that's had conditional on it and you would be good. Okay, are we comfortable about how to check for absolute or conditional convergence now? They are a lot longer than they might seem when all you have is 3 dots to pick, right? And you choose which one. So please don't cut corners. It won't help you in the end. Let's move to our next section then. Oh, I should pause. Any questions before we move?
Yeah, I have a
Okay.
quick question.
Yes, Dylan, what you got?
On the previous part, you used
Mhm.
the same equation, I think. So I'm not really sure how it gives a different answer because
Oh, it's not the same equation. That bit's missing.
true, but you didn't use that bit in the first bit.
Oh, here?
Yeah.
Yes, but when you do an alternating series test, the test doesn't use that bit. Because the theory says that if it's alternating and these are true, then it converges. So the alternating series test is assuming that that's in there. Now, could I stick a -1 to the n plus 1 in here? Sure. But what would -1 to the power of infinity times 0 get you? It would still get you 0. Do you see it clutters up the process rather than helps?
Yeah, I see it. I
So
got it.
it's
Thanks.
kind of in there, but we don't use it because it doesn't affect things and it clutters it up.
I have a quick question.
Mhm.
So when you were doing the proof of the limit comparison test,
Yes.
could we have canceled out the 3n or the 3 and the 3 that's in the 3n?
Here?
Right there, yeah.
Yeah.
Okay, thank you.
And you still get a number and it would still be correct. Right. It hasn't happened because I haven't made any mistakes. But if you make a mistake here, right, in other words, this comparison guy is not actually the one that it should be. You can do the limit comparison test, but you'll know that you've screwed up because this number here won't be a number. It'll be 0 or it'll be infinity. If you ever see 0 or infinity, that's the oops, or somewhere here there's been an oops, because that shouldn't happen, right? If you choose this guy correctly, you will always get a number. Any others? Okay. Our next test. We are finally reaching the end of tests. So the section that we're on, 11.6, is called the ratio and the root test. Today, we're only going to be working on what's called the ratio test. Well, let's tell you how it works. For any series, sigma n, right? Any series that looks like that. So it can be alternating, it can be 1 over n squared plus 1, whatever you want. For any series that looks like that, here's the sneaky thing. If the limit as n tends to infinity of an plus 1, and we'll talk about what that is, divided by an equals L, right? If L is greater than 1, then the series diverges. If this limit L is less than 1, then the series converges. And if L is equal to 0, the test is inconclusive, which means we don't know. And that's called the ratio test. Now, have you noticed that the ratio test looks a little bit like the limit comparison test, right? It's made up of something divided by something. The big difference here is, do you notice that each of these is both in A. So let's just do some skill building at creating these AN plus ones. So can you imagine a series that was called n over n squared plus 1? Yes, question.
Isn't it L equals 1 for inconclusive?
Yes. Oh.
Okay.
Yeah.
Thank you.
Don't know where that came from. Right. Here is a guy. AN is always this piece, right? So that would be this fella. Now, AN plus 1 is essentially what you get when you replace the n's with n plus 1. So it would be n plus 1 over n plus 1 squared plus 1. And then you would tidy up a little bit. And that would get you n squared. That would get you 2n. That would get you 1 plus another one. So AN plus 1 would be this guy. We go. Let's pick another one just to get used to how you get these guys. And suppose I had a series and it was -1 to the n e to the n over n cubed. Then AN would be this thing. Oops. A to the n plus 1 then would be -1 to the n plus 1, e to the power of n plus 1, all over n plus 1 cubed. And I would probably FOIL that out, but I won't bother right now. Are you comfortable with what an AN plus 1 looks like for a series? Don't you just replace every n with n plus 1? Are we good? Now, suppose we got that guy. AN is 2e to the n over n factorial, and e to the n plus 1 is 2e to the n plus 1 over n plus 1 factorial. So when does the ratio test get used? There are a number of series where you can use lots of different tests. And for instance, at the beginning today, didn't we have a question where we could have used the integral test or the limit comparison test, right? So it's not like a series can only have one test on it, right? But in general, you should use the ratio test when there's a factorial in it. So if you see any series with factorials in it, pretty much go for the ratio test. It's always going to be your go-to guy. If you see things with 2e to the n in it, e to the n in it, you know, things like that, ratio test is a candidate, right? If you have a series that only has polynomials in it, like n cubes and n squareds, the ratio test is probably not going to be your friend, because if you use the ratio test, you almost always get an inconclusive. It's not that you couldn't do the test, it's just you don't get anything in it. You don't get an answer when you're finished, right? It tends to be inconclusive. So use the ratio test. When you see the following kinds of things. When you see factorials, when you see powers of n, like 3 to the n. Oh, by the way, it doesn't matter if it has those guys, you can still use the ratio test. Would you agree that you could probably use the alternating series test on that as well, right? So it doesn't make it one or the other, but use the ratio test if you see this. Use the ratio test if you see that. Don't use the ratio test because it tends to not work for things that look like that. For alternating series, you know, look like that. Right, anything with powers in it, don't use the ratio test, right? It tends to not give you good answers. Now, since you're in a section that just is the ratio test, do you realize you're going to use the ratio test for all of them, right? But that's just because this section is about ratio tests. But the big picture we're trying to say here is that these are the kind of guys it's designed for, and it's not very good for these kind of guys. Right? Actually, there's another section after this called strategies for testing, where we give you a series and we say, what would be the best test to use? And to me, the best test, shouldn't it be the one that's the least amount of work? That's your cut today. So let's try that out in a ratio test. Let's see if I can find a homework question. If not, I can make one up. These are pretty easy to do. And n equals 1 to infinity, n over 7 to the power n. This is a question that looks like that. Now I'm going to write down a lot more work than you do, but I'm kind of want to use this as a template. So if you see how this one works, you get an idea of how all of them work. So the first thing I would do is I would write down who the en is. Would you agree that's pretty obvious? You just cover that up and you're looking at en, right? And next to it, write down who en plus 1 is going to be. Are you comfortable that that's en plus 1? Right? Each of these n's gets replaced by n plus 1. So far, so good. Now, so call that step 1. Step 2 would be to find the limit. Oh, just to make everything positive, I'll do that. So we're going to have the limit as n tends to infinity of an plus 1 over an. And that's going to be the limit as n tends to infinity of n plus 1 over 7 to the power of n plus 1 all over an, which is n over 7 to the n. Those absolute values are just to basically to make the thing positive. Would you agree that both these terms are positive? So couldn't I have done away with the absolute values and it wouldn't have made any difference to my answer? The only time these absolute values become important is if the thing inside could be negative. So can you imagine there was a -1 to the n here or something? Right, that could have affected it. So in this case, only because I know that all these terms are positive, I'm doing away with that. At the same time, we're going to have to cope with the fact that we have a fraction divided by another fraction. So I am going to turn this guy upside down. Are you comfortable about why the absolute value has gone away and how this divided by that becomes this multiplied by its reciprocal? You comfortable with that? Right, now what you need to do is to simplify as much as possible first. Sometimes you get away with a lot of simplification, sometimes none. But won't that 7 to the n partially cancel out that guy? So I'm just going to write these two and leave them alone. But what happens when that cancels out that? What's left?
It would just be 7 left
And top or bottom?
on the bottom.
Are you all comfortable with that? Now, once you've cancelled as much as you can, you're going to be left. That looks very weird there. I'll rewrite it again because it looked decidedly like a power, right? You're now left with that guy. Can't you find the limit of that as n tends to infinity by L'Hopital or by dividing the top and bottom by n? I'm going to do L'Hopital this time. And so you get the limit as n tends to infinity of 1 over 7, which is a seventh. Now, conclusion time. This limit is less than 1, right? This is the L guy they're talking about. Since he is less than 1, what conclusion do you make?
It converges.
See it there? It converges. See, 1/7, it converges. Not only does it converge, you get an extra little benefit. It's one of the absolutely converges. Do you see those little absolute values that we put around some? That gave us the extra version. So when you do the ratio test and you get an answer that converges, you actually know that it is going to be absolute convergent every time. Do you like that one? Let's try another one. Do one with a factorial in it. Oops. Yeah, I'll do that one. Now we're going to do the limit as n tends to infinity of this guy over that guy. So it's going to be the limit as n tends to infinity of, if you do an plus 1, you get 3 to the n plus 1 over n plus 1 factorial. And an on the bottom, you get 3 to the n over n factorial. Are you happy about the an plus 1 over an thing? Now, next line, in this case, I'm going to get rid of the absolute values because everything here is positive. And I'm going to take the guy on the top and leave him alone and reciprocal the other guy. So far, so good. Now we're going to see some unusual cancelling, at least in one of the terms. Would you agree that 3 to the n plus 1 will cancel with 3 to the power of n? And what will be left over? And will it be on the top or the bottom?
Three in the top.
Agreed. I think of it as a little battle. Doesn't the big guy win? And the big guy's on the top, so that's where the answer goes. And how much does he win by? He wins by a 3. Now, the next one I'm going to do at the side here, because n factorial, and in this case, what? N factorial also cancel. If you think of n factorial as being 1 times 2 times 3 all the way to times n, and if you think of n plus 1 factorial as being 1 times 2 times 3 times n plus 1, can you see how the cancelling is going to work? When factorials are fighting against each other, right, and their cancelling goes on, don't you get an awful lot of cancelling? In fact, won't these cancel and these cancel and these cancels and so these, and won't this cancel with that? And what's left is a single n plus 1 on the bottom. Are you comfortable about how this thing cancels down to that fraction without any factorials in it? You see the answer is just a 1 over n plus 1. Factorials cancel quite a lot, right? There are a lot of things happen when 2 factorials meet. Now, in this particular one, would you agree that's just a brute force? You can just plug infinity and you're done. So let's do that. 3 over infinity plus 1, 3 over infinity, it's 0. So we know that the limit is 0. Isn't that less than 1? Hey, we've got another absolutely convergent. Are we comfortable with the limit is 0 and anything less than 1 is a convergent? The next one I'm going to do will diverge. But before I do that, suppose that I had 2n plus 1 factorial on the top, and I had 2n factorial on the bottom. Right? We need to see what they end up doing when they cancel. Right? Now in this case, wouldn't the answer be 1 times 2 times 3? And wouldn't the last number be 2n plus 1? And on the bottom, it would go 1 times 2 times 3, and you would finish on the last number is 2n. Wouldn't this number here be 2n? Right? 2n plus 1, the one just before it would be called 2n. Can you see how the cancelling is going to work this time? And 2n plus 1, technically over 1, but wouldn't that just be 2n plus 1? Are we good? Last one. Imagine we got that. 3n factorial on the top, 3 lots of n plus 1 factorial on the bottom. That would really be 3n factorial over 3n plus 3 factorial. This is probably quite extreme. This doesn't happen much, but it could happen. Who's going to win this battle? The 3n factorial or the 3n plus 3 factorial? Who's biggest? Who's going to win? Top or bottom?
3n plus 3.
Okay, so that means it's 1 on the top then, right? How many things are going to be left over? How many are, once this cancels that and this cancels that and this cancels that, how many things are going to be left on the bottom? So imagine going 1 times 2, right? And wouldn't the bottom be 1 times 2 times 3n? And the 3 that you said, wouldn't they be 3n plus 1, 3n plus 2, and finally 3n plus 3? Can you see a shortcut way of figuring that out? Don't you just look at what's left from 3n to get to 3n plus 1? Don't you have to do a 3n plus 1, then you have to do 3n plus 2, and finally you have to do a 3n plus 3. Can you see that this cancels to that? Are we good with that? I don't know if we're good with that. I'm getting one kind of worried look, and that's all I can see in faces. Do you want me to get into more detail of why these two cancel to give you that? Or are you comfortable with that's the answer? You've got to help me here, guys. I'm not a mind reader. I really do need some feedback. Are we good? Okay, we're good. Well, let's show you a divergent, because divergence happen. Let's do sigma n equals 1 to infinity. Put in one of those guys. Put in a factorial. And put in that guy. So we're going to do the limit as n tends to infinity of an plus 1 over an. In this case, since the answers are negative, I do have to spend a little bit of time worrying about them. So -1 to the n plus 1, n plus 1 factorial over 4 to the n plus 1. So that's the top term. And on the bottom, we get these guys. First thing I'm going to do is I'm going to remove the absolute values. And you're going to say, wait a minute, if this guy cancels with this guy, isn't the answer still -1 left behind? What's the absolute value of -1? Just 1. You see, it has no effect. It basically dies, right? So the absolute values here, the net effect they have is that these two guys don't matter because they end up being +1. So what I've now got is n plus 1 factorial over 4 to the power of n plus 1 times turn the guy upside down, right? Don't need absolute values now. Four to the n has a fight with 4 to the n plus 1, and the 4 to the n plus 1 wins, and there's a 4 left over. N plus 1 factorial has a fight with n factorial. Who wins? And where does the answer go? And where is it? What do you get when you cancel those?
Plus 1.
In this case, it's just a single n plus 1. You agree? Now, would you also agree that you can do a brute force on this one? And the answer is infinity. And L is infinity is definitely bigger than 1, right? So we know the series diverges. We don't say things absolutely diverge. You know, if you diverge, you just diverge. Are you comfortable about the ratio test also tells you when things diverge? So let's show you an inconclusive. Almost a -1 to the n, right? And yeah, let me redo that one. I've got a feeling that one actually might come out as conclusive. So what do I want? I'll do an n cubed. That's better. So this one's going to be inconclusive. This one is also not going, I must fingers crossed this is going to be inconclusive. I'm sure it will. And secondly, I'm picking this one because wouldn't this one be much better to do as an alternating series? Right? So this one is not, is one that you shouldn't do the ratio testing. So it's not that you can't do it, but nothing good comes out of it. So it's going to be the limit as n tends to infinity. Okay, on the top, big ugly fraction, on the bottom, another one. So it's going to be -1 to the n plus 1, n plus 1 cubed over n plus 1 to the 4 add 1. And on the bottom, this guy. The absolute values are going to kill these guys off, so I don't really care about it. So all I'm going to be left now with the terms that we have is that guy over that guy. So far, so good, right? Now,
Professor, can I ask
Yes.
a quick question?
Yes.
when we're doing it on the test, do you want to see the extra line with the absolutes and to cancel out those negative ones, or can we kind of skip
Yeah,
past
no.
the next line because they always cancel?
Show me. They do
Okay.
always cancel, but it's part of the proof. Right. Now, this horrible guy, and I'm beginning, I wish I'd chosen smaller pairs, but I've committed, so I'm going to do it. This guy becomes n cubed plus 3n squared plus 3n plus 1. You're just going to have to trust me on that. This guy is going to be n to the 4 plus 1. This fella is going to be n squared. It's going to be n to the 4, I should say, plus 4n cubed plus 6n squared plus 4n plus 1. And you're wondering where all this comes from. It comes from a little thing called Pascal's triangle. Look it up. So that's what this is, right? So all of that plus a 1, right, times an n cubed. And do you already see why you shouldn't be using the ratio test when it's polynomials? Can you already see how ugly the thing is became? Right now, if you multiply all of this together, I'm going to cheat a little bit. Would you agree that you get n to the 7 plus a whole load of stuff like 6s and 5s and 4s, and you finish with a plus 1? And if you multiply all this, you get an n to the 7, and you get a 4n to the 6, and a 6n to the 5, and a 4n to the 4, and there's 2 of them, so you get 2n cubed. Right. I just haven't bothered foiling that, but can you trust me that there would be some n to the 6s there? What would they be? They'd be 3n to the 6, for instance, eventually. The reason why I don't worry about the rest of these terms is, if you look at this carefully, can't you just divide the top and bottom by n to the 7? So if I divide the top and bottom by n to the 7, I will get the limit as n tends to infinity of 1 plus 3 over n plus some other stuff like 3 over n squared and 5 over n cubed, and finishing with that guy. And on the bottom, I get 1 plus 4 over the n plus 6 over that guy plus 4 over that guy plus 2 over that guy. And when you do a brute force in that, doesn't everything else just become 3 over infinities, and you get 1. And 1 is inconclusive. And every time you have a polynomial on the top and a polynomial on the bottom, whether or not this guy is there or not, the ratio test is just going to tell you it's inconclusive, which means we don't know if it converges or not. If I did this with an alternating series test, wouldn't it converge? You can imagine it, but it would. So have I convinced you why you shouldn't use the ratio test for fractions that have only polynomials in them?
Yes.
Good, because that was the goal. So we basically covered, I'm going to do more of these, but we basically covered the 3 situations, haven't we? If you get a limit L, if this is a number and it's bigger than 1, it diverges. If this is a number that's smaller than 1, it absolutely converges. And if it's equal to 1, the one we just did a minute ago, it is inconclusive. And only use ratio tests when there's factorials in it and 3 to the n's in it and things like that. Do not use it when it's got fractional polynomials in it, because you just get inconclusives, and it's a lot of work to get an inconclusive when you're finished. And perfect timing. So last name and bye-bye. And I'll hang about for any questions.
Hey, I thought that I had like gotten why the 3n factorial over the 3n plus 3 factorial equaled the that one thing, but I'm not make sure. Could you go over that again?
Sure.
Sorry.
No
you.
problem. The trick to doing that is to try and write down the thing in full. I know it's impossible, but at least a version of what it would look like. So there's 3n factorial, right? Put a bracket around it. And there's 3n plus 3 factorial. So when I see 3n factorial, I think of 1 times 2 times 3 times all the other numbers, and you'd finish on whatever number 3n would be. Are you comfortable that that's what 3n factorial would look like?
Yeah.
Right. Now, if you do 3n plus 3 factorial, it also starts with 1 times 2 times 3, and it finishes at 3n plus 3. Now, what would be the number just before 3n plus 3? What would be the expression? If that's 3n plus 3, who would this count?
Oh, it'd be 3n plus 2 and then 3n plus 1.
And then after that, wouldn't you eventually get a 3n?
Oh, and then it just, oh, okay, that makes sense.
Everybody dies, they 3 live. And that's
All right,
where
that
it
makes
came from.
sense. Thank you.
Okay.
But
Any other questions from anyone? Are we good, Maggie?
I
David?
did have a question.
Sure, what you got?
So with the factorials, if we know that, like if it's like you have the 2n plus 1 factorial divided by the 2n factorial, if we know how that's gonna go, are we expected to show it on a test? Or is
Yes,
that part of the, okay.
yes, it's part of the proof. And what happens, and it's good that it does happen, but it's you still have to kind of prove things, is that after a while you start saying, yeah, I know what that's going to happen. Yeah. Now, what you can do, and I think this is totally valid, can't you just write down that? You don't need to do this bit.
Okay,
And so
wonderful.
if that's what you're asking, no, you don't need to do this bit. But that's kind of what's happening in your brain, right? But all that would
Right.
really be written down would be this.
Okay,
Okay.
alrighty, thank you.
You're welcome.
I did want to give you a heads up. Next Friday on the 28th is one of the days that I won't be able to make it to class.
Okay. Watch the video. Is anything special happening that Friday? Not that I know of. It's just a normal day, isn't it? Yeah. So you should be able to catch up by watching the video. I don't know anything's happening on the 28th. No.
Okay.
Is that not going to be the Monday after that's going to be the midterm? Is that too far away?
I
No,
don't know.
it's one more week. It's not. It's the following week. So nothing special's happening that Friday. So just catch up and you should be fine.
Okay, thank you.
Okay, bye-bye.
Bye.